Hi, it's Jashandeep Singh. My student ID is 9914111298.
Hello guys, my name is Jaspreet Singh Sidhu and my student ID is 9914103330.
Hi, my name is Gurpreet Singh and my student ID is 9914183328, and today we are presenting the lab about the Izod impact test to check the strength of the metals, specific metals. The purpose of this lab is to see the strength of all three metals. The metals are brass, aluminium and steel. So the sizes of these metals are basically same, except the thickness of notches are different. For example, steel has bigger notches because it has more ability to absorb. Also, it is more stronger than the other two metals. Here are some pictures of the metals that you can see. The objective of this Izod test is to learn about the metals which are the stronger and which are the weakest. And we also learn how to use the pendulum tester. The theory of this experiment is to see the fracture limit of all three metals. We are going to use several formulas in order to identify the initial and final potential energy, also the amount of kinetic energy which requires to break the metal, difference in initial height and impact velocity. By using these formulas, we are gonna be able to find the difference between initial and final height, also the potential energy of all three metals.
My name is Jaspreet Singh and my student ID is 9914103330. And as my friend Gurpreet Singh has explained about our theory and objective, and now I'm going to start with the operators used in this lab. The main operators we are using in this lab are the scale, anvil, pendulum, hammer, and the three specimens that we have: the steel, brass, and aluminium. And then there is a vernier caliper that we will use to measure the thickness and the width of the notch at the different specimens. Okay, and then there is our machine that's called the Izod impact. And here we have the pendulum, and then here is the reading for the impact energy. Once we get the impact energy, from there we will take out the impact strength. And now starting with this, make sure when you are putting any piece, like I have the piece called the brass in my hand, and then as you can see, there one part is smaller and then the other is bigger. And then while putting it in the machine, there is one sport we have to put it in the machine, and make sure the smaller part is upward and the longer part is down. At the back, and then I'm going to put our specimen in this, and then after fixing our specimen, we will use this, you can say, like to tighten it up, and then after tightening it up, make sure your pen is at the 54 feet per pound. We have to see the readings that are in the orange color, as my friend will show you, the 50 and 40 and 30, and this will give us the impact energy. After we get the impact energy, then we will take out the impact strength. Like before I have said you that we have taken out the area for our notch. By dividing the impact energy with the area of the notch, we can take out the impact strength. And after that, we can compare the impact strength of different specimens that we have: brass, steel, and aluminium. Okay, then guys, I'm going to lock the door for the safety procedure, and then after that, guys, I'm going to release our pendulum, and as you can see, there are the 3 points. There is latch, there is release, and there is break. And I'm going to release my pendulum. I will take out the pin from the number 1 position, and then I will put it in the number 2 position, that is called release. And then I will take this to the release position. Okay, and then our pendulum goes, and after that, and after the experiment, like your pendulum has done its rotation, and then you can take your pin and take this to the brake position. And after your pendulum gets stopped, as you can see, our pendulum is at the stop position. And then now you can take it back to the latch position. And in this way, like we are done with our with our brass thing. As you guys we are done with the main part, and now we get the reading for our brass specimen, and we get the reading as the it is 4 feet per pound is the impact energy for the brass. It means that the 4 feet per pound energy is required to break that specimen of the brass. And then after that from here we get the impact energy. And the another use of this scale is that we are going to use this scale and to find our angle of rise, which would be used in our further calculations. And then we can put our this scale like this, and then let me fix it here. And as you can see that from here we can get that our angle of rise for the brass is 62.5 degree, and in this way our experiment is about and we can follow the same procedure for the different specimens. For the other specimens we have the steel and the aluminium. And I want to show you the pieces of the brass that we have done the experiment with. Wait a second. Okay, and here you can see the pieces of the brass, and it's and in this way we are going to compare another 2 specimens, and further my friend Jason will explain you about that. Thank you. Guys, as we have done our Izod impact in the lab, and now I'm going to explain you the data that we have taken from the lab. And as you can see, like first of all, we have done our calculation with our vernier caliper. We have done the dimensions we have got for the notches are for the brass notch it's 7 millimeter, for the aluminium notch it was 7.06, and for the steel it was 6.57 millimeter. And then we have the thickness that we have measured, 9.43 for brass, 8.70 for aluminium, and 9.50 for steel. And then afterwards, when we were doing the experiment, we have used the scale for measuring the angle of rise that I have explained before. And the angle of rise we have got for the different specimens are the brass. For brass we have 68.5 degree angle of rise, and for aluminium that was 71 degree, and then for steel it was 47 degree. And now I'm going to explain about the energy absorption. Energy absorption is what the readings we get on the Izod impact, the machine we use. In that, as we can see that the energy absorption is basically the amount of the energy used by the machine to cut out that specimen. Like for cutting this specimen of steel, we get the energy of 36.6 joules, and for aluminium that was 8.8 joules, and then for brass it was 5.4 joules. And as you can compare that for steel we need a lot of energy to break that specimen down. So that's why this steel is more stronger, and then comes the aluminium, and then is the brass.
Hi, it's Jashandeep Singh. I just explained you all the experiment procedure and the data part. Now I'm going to explain all the calculation part. And first of all, we are going to calculate first of all, to verify the initial height of pendulum. In this we have given the radius of the pendulum and the cos alpha. Alpha is the initial angle, and we have given it the value 73.5 degree, and we have calculated the initial height as a 572.7 millimeters. Now second part is to verify the impact velocity, and in this we have to use the formula under root 2 GA, and it's A is the initial height, and G is the gravitational force, and it's the 2 into 9.8 and 573, and as we have verified it is at 3.35 meter per second. And then third is pendulum arc height after the impact, and it depends upon the angle we have calculated in the different materials. And for the brass it is different for the aluminium. As for the brass it is 5.07 meter, aluminium 0.539 meter, steel 0.254 meter. And now the potential energy. As the initial potential energy, we calculate by this by mga. A is the initial height, and the final is mgb, and b is the final height. For the final potential energy in the brass, it's 59.97 joule, aluminium 63.76 joule, and for steel is 30.04 joule. Now the energy required for the sample breakdown, and it's a formula for this is mgr cos beta minus cos alpha. Cos alpha is the initial angle and beta is the angle we have taken after the breakdown. For the brass it is 7.80 joule, for the aluminium it is 3.93 joule, and the steel is 37.7. As we have seen, for the steel the energy of breakdown is very high. Now the percentage of error. As we have calculated the energy values and we have measured the energy values, so we are going to calculate the percentage error. For the aluminium, the percentage error is minus 123.9, as our measured value is below than the percentage error. For the brass is 30.77%, and percentage error of steel is 2.92%. And now the ISO and ASTM impact strength for the materials. For the ISO impact strength, it is calculated by the energy by the total area of the element, that is the area of notch. And for the ISO aluminium, it is 15720 joule per meter square. The ISO for brass is 31,200 joule per meter square, and for the ISO steel is 1,45,000 joule per meter square. Now for the ASTM. ASTM is energy by the thickness of the element. For the ASTM aluminium, it is 561.40 joule per meter, and for ASTM for the brass is 8 to 9.8 joule per meter, and ASTM for the steel is 5712 joule per meter. And as we seen, as by comparing the ISO and the ASTM, as we seen, the energy for the steel is very higher than the other aluminium and the brass. As we seen in the experiment, as a result, steel didn't break down in the pieces as the brass and the aluminium did. So we can say that the steel has a higher shock absorbing capacity than the aluminium and the brass. So we can say that the steel is the strongest one, and as compared to aluminium, brass and aluminium, we can say the mid-ranger, and the brass have the lowest shock absorbing capacity. In order to get accurate data in the experiment, we have to take care of the different kind of error. For the first one, we should terminate the parallax error. As we taking the readings, we have to be as vertical to the reading scale so we can take it properly. And in order to get accurate data, we have to use digital meters for the calculation of lengths, and we can use analog meters instead of old equipments. And as we have to place the notch of the material, it should be properly accurate so that pendulum can hit it in the right place, so we get the right readings. So that's all discussion.
During the experiment, by the help of calculations, as we can see, the steel has the highest impact strength than the other two metals, which are brass and aluminum. As you can see, the brass and aluminum are the weakest one. As you can see over here, so this one is the steel, which is like little twisted, and look at this one is brass and this one is aluminum, which are totally broken. So therefore, brass and aluminum has less capacity contrasted with the steel. As you can see, steel is a malleable metal and has a shock absorption far better than the other two metals. So the purpose behind this lab was to research the metal toughness resistance to the effect from swinging the pendulum. The use of Izod test is one of the best methods to assess the impact of toughness and the most commonly used for controlling the quantity because it is real quick and most accurate and efficient method.